In today's lesson, we're going to introduce two more of your circle theorem facts. It's really important that you remember the circle properties and the circle theorem facts from last lesson. If you have forgot them, please go back and watch the video from last lesson to remind yourself. Some of the questions from today will incorporate the circle theorem facts from last lesson. You'll have to look out for these as well as the two new circle theorem facts that we introduce. The first of these facts is on the screen for you right now. This one we refer to as the bow. Hopefully, by moving the points around, you'll be able to spot something about the angles inside the bow. Hopefully what you noticed is that the angles at the top of your bow are always equal and the angles at the bottom of your bow remain equal as well, regardless of where the 4 points are on the outside of your circle. It's really important for this circle theorem to work that you make sure all 4 points of the bow are on the circumference of your circle. What we can say is that angles in the same segment are equal. So let's have a look at some examples of this. Firstly, we need to make sure we get the orientation of our bow right. Now if you think about wearing a bow tie, the 2 points at the top will be equal and they'll be pointing upwards. The other 2 points at the bottom would be equal and they'll be pointing the other way. So in our example, we can see the 2 points at the top, which are W and 35, they're going to be equal, so therefore I can say that W is equal to 35 degrees. I can also say the same about the angles at the bottom, so this 43 and angle X, because they're both at the bottom, I can say that they're equal, so therefore X is equal to 43 degrees. The second example is a little bit more complicated than this. We're going to need to use some of our angle facts as well as our circle theorems to help us find the missing angles. So I'm going to start off by working out this angle just here, and I can get that because angles on a straight line add up to 180. So I need to do 180 take away 137. First of all, if I borrow, I get 10 take away 7, which is 3, 7 take away 3, which is 4, and 1 take away 1, which is 0. That gives us an angle of 43 degrees. I can now use my bow circle theorem to say that Y must be the same as that angle, so Y is also 43 degrees. To work out my next angle, I first want to work out the angle at the top of my bow just here. I can do this by considering angles in a triangle adding up to 180 degrees. Looking at the angles that I'm given in my triangle, I can first say that 93 and the 43 degrees that we're given give us a total of 3 add 3, which is 6, and 9 add 4, which is 13, so we have 136 degrees of our triangle so far. If I take that answer away from 180, I can work out what the missing angle is. So I'm going to start off by borrowing. I get 10 take away 6, which is 4, 7 take away 3, which is 4, and 1 take away 1, which is 0, meaning that this angle at the top is 44 degrees. Again, using our bow circle theorem, that must mean that the angle at the top for Z is also 44 degrees. This is my next circle theorem fact for today. It's called a cyclic quadrilateral. That's because we have a quadrilateral within a circle. Just notice how all 4 points of our quadrilateral lie on the circumference. Again, by moving the points of my quadrilateral around, we should be able to spot something about the angles inside the shape. what we can spot is that opposite angles in our cyclic quadrilateral always add up to 180 degrees. You can see in our example we've got 86 and 94, which are our two purple angles. They add up to 180. We also have 93 and 87. They're our orange angles. They add up to 180 degrees as well. They're opposite each other in the cyclic quadrilateral. We can therefore say opposite angles of a cyclic quadrilateral sum to 180 degrees. Again, you can see that this remains true regardless of where I move my points to. So let's have a look at a couple of examples of how to apply this. In my first example, I'm asked to find angles W and X. I know because we've got a cyclic quadrilateral that angle X and 92 must add up to 180 degrees. So I can do 180, subtract 92 to work this out. I can start off by borrowing. That gives me 10 take away 2, which is 8, 17 take away 9, which is 8, and 0 take away 0, which is 0, meaning angle X is 88 degrees. I can do the same for angle W. I know because of our cyclic quadrilateral that W and the 70 degrees we're given opposite must add up to 180 degrees. So 180 take away 70 gives me 0 take away 0, which is 0, 8 take away 7, which is 1, and 1 take away 0, which is 1, meaning angle W is 110 degrees. The second example is a little bit more complicated because you need to use some of your other angle facts to help you work out the angles that you need. So, thinking about what will help me, I first want to think about how I can get this angle just here. That's the one that's opposite Z in our cyclic quadrilateral. Now, in order to work this out, I first need to recognise that this angle here and this angle here are equal because our triangle is isosceles. That's because this length and this length both represent the radius of our triangle. I'm going to start off by doing 180 take away 96. In order to do this, I'm going to need to borrow. That gives me 10 take away 6, which is 4, 17 take away 9, which is 8, and 0 take away 0, which is 0. That means that both of my red angles must add up to 84 degrees in total. Because I know both of these angles are equal, I then want to divide 84 degrees by 2. I can use a bus stop to help me do this if I'm unsure. That means 8 divided by 2, which is 4, and 4 divided by 2, which is 2. So both of my red angles are 42 degrees. I can now work out my larger blue angle because I know that that's equal to 42 plus 56. So let's work this out. We get 2 add 6, which is 8, 4 add 5, which is 9, meaning my blue angle is 98 degrees. Lastly, I know that angle Z and this 98 degree angle that I've just worked out must add up to 180 degrees because of our cyclic quadrilateral. So I need to do 180, take away 98 to find out what my missing angle Z is. I need to start off by borrowing. I get 10 take away 8, which is 2, 17 take away 9, which is 8, and 0 take away 0, which is 0. That means that angle Z is 82 degrees. So, your task for today is to complete the 2 worksheets on the bow and cyclic quadrilateral circle theorems that I've attached to show my homework. As I mentioned at the start, some of your circle theorems from last lesson will be included, so look out for them. Please pause the video and have a go at the questions, and when you're ready for the answers, you can unpause. Here are your answers. Please check your work extremely carefully, and once you're happy, take a photo and submit it to show my homework so I can see how you've got on. If you are struggling to complete some of the work from today's lesson, then please do not hesitate to get in touch via comment on Show My Homework. I'll try to make myself as available as possible and get a reply to you as quickly as I can. If the issue requires a little bit more input from myself, I might ask to arrange a time to meet on Teams where I can give you some personalised help with that specific problem.